Morning, guys. Who's excited to talk about security? All right. So how many of you guys have a CapitalOne bank account? Wow, that's actually pretty good. And how many of you guys want your money and personal information to be secure? That's pretty good. It looks about 100%. Yeah. So being an engineer, a software engineer in a bank, security is one of the most important things that we do, right? We have your actual money in the bank. We have your personal information, things like social security numbers and addresses and date of birth. We have, in some cases, we have your external bank account numbers where your other money is, right? So you definitely don't want that information to be compromised. So we actually spend a lot of time and effort trying to make our system as secure as possible. And I really believe that security starts with the development team that actually builds the application. It can't be an afterthought, right? I can't rely on somebody else to look at my application or to scan it to make sure it's secure. I actually should try and design it and build it in a way that's secure. So we're going to talk a little bit about one of the aspects of security today. So what is the problem that we're trying to solve? Let's go back to what happened previously in kind of a traditional development ops world, right? Before we had continuous delivery, before we had DevOps model that we're following now, we had the setup where the application team builds the application, right? And the application probably talks to some databases or some APIs or web services outside, and it needs credentials to access those things. So how did we get production credentials to the servers that run the application? Well, there's a couple different ways that was done, right? One way was the application gets deployed to some static server, usually, and the ops team logs into that server and manually types in the credentials in some property file and saves it. And the other way was if we had some automated deployment process through like a Jenkins job, right, that pushes the code, maybe the ops team will actually type the credentials in the job parameters kind of thing, and it will get somehow propagated to a properties file to the server. Well, we can't do that anymore. So the model that we went to was a fully automated, fully immutable infrastructure, right? So there is no step where somebody else who is not part of the development team could actually come in and type in those passwords. So the three things that I want to talk about here is first, the model itself, the immutable infrastructure. If I deposit the secret somehow on the server, the next deployment, the server will be wiped out, so it doesn't really help me, right? I need to actually automate some way to deliver those secrets to the server every time I deploy something. The other part of it is I really like the idea of source control of everything. I want my entire infrastructure to be source controlled together, right? I don't want my secrets here and my code there and my infrastructure somewhere else. I want the whole thing, including secrets, in one place. Because if you think about it, especially secrets that are application secrets, things like database passwords, they kind of evolve together with application itself. Tomorrow I might be talking to a different database or to an additional API, right? And I want that change to be reflected in my GitHub history. And I want that change to actually trigger a deployment that makes that change happen. I don't want it to magically, just happen in production. So the model that we are going with is a full DevOps model, which means the developers who actually write the functional code and the infrastructure code are the developers who get calls and emails to actually go fix the issues in production, right? And the problem is that so there's some regulations that actually prevent us as a bank from allowing developers to have full access to production. So there's something called segregation of duties, which is one regulation that we have to follow, which basically says that the same person who writes the code cannot have access to mutate production. The intention is really to prevent people from releasing code that steals the money and gives it to themselves kind of thing, right? We don't want that. We don't want kind of an office space situation. Even though in office space it was more than one person, and that could still happen, the regulation doesn't prevent that, but you have to have good friends in different places, which is a little bit harder. Most importantly, it's not just the regulation, right? It's actually the right thing to do. So I'm sure all of you guys who have CapitalOne accounts, we have thousands of employees in the company, and GitHub is open within the company. Anybody can go look at the code. You don't want thousands of people to be able to go look at database passwords that contain your personal data. Even though the vast majority of those people are good and they have good intention, I don't think any of us would feel comfortable with that. So the problem really becomes, how do we fully automate this without exposing database passwords? And it's kind of a chicken and egg problem if you think about it, right? So I find some way to encrypt my secret, I put it in GitHub, but then how do I decrypt that secret, right? How do I get whatever the keys that I use to encrypt it to the server? Again, the server is being created every time I deploy the application, and the only things that I'm deploying to the server should come from GitHub. And again, you have that problem where whatever I encrypt has to be decrypted somehow. And in order for me to decrypt it, I need to have a key, and where do I put that key, right? So if you look at something like Chef, for example, with encrypted data bags, I don't know if you guys are familiar with, probably most of you guys are familiar with that pattern. You have to have a secret key somewhere, right? And I have to deliver that secret key to the server in order for the Chef round to actually decrypt the data bag. Well, how do I get that key to the server? I have to put it somewhere in GitHub. And we don't use Chef server because we are following fully immutable patterns. We don't want like a Chef client to run. We just run one Chef 0 execution at the startup. So most of the standard solutions that are out there, at least we couldn't find one that fully supports what we want to do. There's Vault that's kind of on the verge of supporting something similar to what we did, but it's not quite there today. So I'll talk about that a little bit later. So we actually decided, because we're fully in AWS, we decided to use the AWS services we already have available to authenticate the server that's trying to access the resources. And I'll give a little bit of background on how IAM works in general. So IAM roles in AWS allow you to not only give access to people, but also to other AWS resources. Right? So you can assign AWS IAM roles to an EC2 instance. The instance can assume that role, which under the hood, when you actually do that, it generates temporary keys that it uses to sign API calls to other services, right? So we already rely on that for several things. Like if we make a call to other AWS resources like S3 buckets, we use IAM roles. If we make calls to SQS or SNS or even DynamoDB, right? All of that relies on IAM roles. So we already use IAM as a security mechanism for critical things. So we decided, since that's already there in Amazon, why don't we just use that to solve our problem? So essentially the idea is that if we trust that this server, only this kind of application server, can have this IAM role, why don't we tie the ability to decrypt a secret to proving that I have the IAM role, right? So a little bit of background on KMS. So KMS is a AWS service that provides some services for encrypting and decrypting data, right? So you can actually encrypt data and decrypt data as long as you have access to that key. So the interesting thing that we found, KMS actually supports this concept of encryption context, which is essentially additional salt you add to the data you're encrypting. And you can actually create KMS policies that restrict the ability to decrypt a secret to IAM roles that, or to calls that pass a specific salt, right, a specific context. So here's an example on the slide of how you would actually create a KMS policy to enforce that. So what this does is it says, okay, that role called my IAM role in that account has the ability to decrypt only if the encryption context has app name equals my context, right? So any other type of decrypt call from that instance that has that IAM role with a different context will fail with an access denied error. And any attempt from an instance with a different IAM role with this context will also fail with access denied error. I got, of course, XKCD there. It's one of my favorite. Actually, when I was looking at this one first, I fell for it myself. I was wondering, like, what is Alice and Papa going to do? Yeah, so the protocol that we came up with is essentially fairly simple, right? You create a KMS, a master key in your account. You create an IAM role for your application servers. And typically, in most cases, at least for us, we already have IAM roles for our application servers, individual roles for individual applications, because they already have to access things like S3 buckets or whatever it might be that application uses. So that usually is already there. Then you create a KMS policy, like I showed in the previous slide, that restricts access to decrypt values with a specific encryption context only to instances that have this role. And then you encrypt the value. So the encrypt access, you could give it to your Jenkins instance, which is what we did. We gave our Jenkins instance the access to encrypt anything with this key, right? So we have a job that will go and you type in, here's my context, and here's my plain text secret, give me the output. So it gives you a long string that you go copy and put into GitHub, right? And at this point, your developers see a long string that they can't use to actually, log into a database, but the application server can decrypt when it gets deployed. So deployment time when Chef runs, we use Chef, but you could use anything with this concept. When Chef runs, it actually reads that encrypted value from a data bag, and it makes a call to a KMS API. And at that point, it works because that instance where it runs actually has the IAM role that has the permission to decrypt with that particular context. So one of the problems that IAM has in general, and maybe it's not a problem, it's just something to be aware of. That's how it works. So the way IAM works on EC2 instances is that there's a magic IP that you have to make a call to that returns your temporary keys, right? And even if I'm a developer who has a read-only access to that instance, right? I can't sudo, but I can just SSH to it as myself. I still could make a call to that magic IP address and get credentials, and then you kind of get around the whole system, right? Which is a problem not just with this particular protocol, but a problem in general. If I'm trying to limit access to something that already works as part of the AWS ecosystem, like S3 buckets or DynamoDB, if any developer who has read-only SSH access to the instance can log in, they could go and query the DynamoDB table, right? Which is not really good. So what we did was we added something extra to the way we deploy applications. So we added the AP tables, which is a firewall for Linux. So what we did was we blocked anybody who is not in the whitelisted set of user groups from accessing that magic IP. And that's done again at bootstrap time by Chef. Right. So now that any developer who does not have root access can log into an instance and go look at logs and troubleshoot stuff, which is what we want, but they can't actually get around the fact that they don't have the visibility to the plain text passwords to our databases and external APIs, and they also cannot make calls to this metadata IP to get those credentials to decrypt the secrets. There's a little bit of shell script down there with an example of how we're actually doing this. So as I already mentioned, we use Chef today. So what we've done to automate and simplify all of this, we actually created a couple of cookbooks. So we created a cookbook we call Briefcase, which just abstracts this idea of decrypting secrets in different ways. And one of the ways we implemented is this KMS decryption. Right? So all we have to do is we put the encrypted value into a data bag in GitHub, committed to GitHub, right? And then we run this Briefcase cookbook to decrypt it at deployment time. So there's a few really good things about doing that with something like Chef, is that I could actually enforce in my code that is reused by multiple development teams. I could actually enforce that the file where I put the decrypted value has certain permissions, right? I could actually enforce that it's not readable by everybody, because that kind of defeats the purpose again. And we did the same for IP tables. So we created a little recipe that basically to configure IP tables to block the magic IP. So as I mentioned before, we didn't really find any great solutions that are already out there for this problem. We looked at a few. So here's just a brief review of what we found. So Vault is actually, there's been a long-standing open issue in Vault about this, and people gave ideas that had some similarity to what we did. And Vault is actually looking to build something similar using EC2, essentially signatures of EC2 instances, right? Which is essentially the same thing that you're trusting IAM roles. So they're actually using the signed EC2 identity document, which again you retrieve from that magic metadata IP, and they use that to prove that you are the instance that you claim to be. So right now that solution only supports authorization using AMI ID. So if you have the same AMI that you use to deploy multiple types of applications, that's not really going to solve the problem. And the other more maybe philosophical problem, at least my ideal solution would be to actually source control the secrets together with the application in some encrypted form. But the way that Vault is trying to solve this is you actually put the secrets in Vault and you make an API call at runtime or startup time to actually get the secrets, which has its advantages. But the downside is that you're not actually going to see that something changed in your GitHub history. So that's the presentation. Do you guys have any questions?
Yeah, quick question. So I kind of missed the part where the Jenkins server encrypts the key and encrypts the secret. How does it get the secret?
Yeah, so somebody, some person still has to know what the actual password is, right?
So are they putting stuff into some shared location, or that Jenkins goes off and reads it? Or
no, so whoever has the actual password, there's probably 1 or 2 people, right, who actually have the password. Whoever created the database, let's say, right? They have the password they created when they actually set up the database. So that person will go and run the job.
But they will put that into the job in Jenkins?
Yeah.
So you said that one design thing with this versus Vault is having the key and version control versus generating it with Vault. So Vault, I think it's interesting that they have the concept of leases, so they encourage you to call the API, but then when you get a secret, it's got a time period.
Yeah.
So I'm wondering with your system, since you don't do something like that, what do you do for rotation of secrets?
Yeah, no, that's a great question. It really depends on what kind of secret you're talking about, right? If it's let's say you have a MySQL database and you have a password to the database, right? You're not going to really have Vault go change the password automatically and give you a new one. So that still has to be done by somebody most likely, right? So for those types of things, I don't think you would use Vault to rotate keys on you. You would still want. But then you have to give Vault itself root access to your database to be able to do that, which again is in of itself maybe a concern for some people. Yeah, I mean I can also see the value in doing that for some use cases, definitely.
Thanks. So fixing the limiting IAM with the IP tables rule is a pretty slick trick. I've never seen that done before. Do you have a way to so other non-root users may need the IAM endpoints, or sorry, not the IAM, but the EC2 metadata endpoint. Do you have a way to still allow non-root users to query that endpoint and just restrict KMS? Yeah.
So the Chef cookbook that we wrote, and could be done in anything, it doesn't have to be Chef, right? So what it does is you can parameterize a list of user groups that have access, right? And then it will generate the right IP table configuration so that only those groups have access. So for example, if I have a Java web app that runs on Tomcat under Tomcat user, I could give Tomcat access to query metadata.
Thanks a lot.
Thanks.